Today we are going to talk about the quadratic equations. When you say quadratic equations, so it has a polynomial function like this. So y is equal to ax square plus bx plus c. So you have number of unknowns in here, and you have two variables in here. Two variables are y and x. We know when y equals x equals according to the relationship given in this formula. So equation, right? So this is a polynomial form of quadratic equation. This standard format of the polynomial form of this equation, ax square plus bx plus c. So unknowns are the constants. So unknowns include three constants. So what are the constants here? So A, B, and C are the constants. So X and Y are variables. So now, so if we learn this polynomial form, right? So what kind of graph you can get from this polynomial form? So in that case, right? So we take the very simpler or most simplest form of this equation. So that is, so just say y equals x square. So x square is essential, right? So y is equal x square, right? So x to the power 2. So that x to the power 2 part is essential. So in that case, you can see, right? So we tabulated some values for x. For example, -3. Or tabulated some values for y, right? So y is equal 4, 1, 0, right? 1, 4, 9. So having said that, okay, we'll put this way. So put the x numbers first, right? So -3, -2, -1, 0, 1, 2, 3, right? So then find out the y value of it, right? Y value would be, see, x square. So -3 square is 9, -2 square is 4, -1 square is 1, 0 is 0. So 1 square is 1 itself, so 2 square is 4, and 3 square is 9. So you can see, right? So it will produce this kind of graph, this particular shape of the graph. So this graph we call a parabola, right? So parabola. So what kind of parabola you get from y is equal to x square, right? So what are the characteristics of this graph? So okay, so when you describing a graph, so you would like to express yourself by few ticking points. So ticking points mean so the way we describe this graph. So first of all, to describe the range. So what is the range? The range is the actually it is the range where the y coordinates are lagging, right? So y coordinates of the graph, right? So spreading from one end to the other end. So that is what we call range. So in this case, you can see, so y coordinates can go up to negative. So this is, y is equal to 0 line. So y coordinates can go up to the infinity, right? So positive infinity and 0 and positive infinity on the other side, right? So both sides with respect to y is positive infinity, right? So what is the lowest value for y? The lowest value for y is 0. So then you can describe the domain. What is the domain of this graph? The domain is the range where the x-coordinate are spread. For example, in this case, so x-coordinate can be vary from negative infinity to positive infinity. And again, right? So negative infinity to positive infinity. See? So in between, it is come to a certain value of x, which is x is 0, or x is positive 0. So this is the 0, 0 point in this case. In this graph, quadratic equation, y is equal to x squared, which is the most simplest form, right? So you can find the 0, 0 point, right? So if you look at more details on this 0, 0 point, so if you actually put a line over here, right? So I'm talking about y is equal to 0 line. Oh, sorry, x is equal to 0 line. So this is y is equal to 0 line, right? So this is x is equal to 0 line. So x is equal to 0 line where all the way in this line, the x value is 0. So that is the symmetry of this graph. If you look at this, so your left-hand side of the equation is similar or the same as the right-hand side of the equation. So this is the symmetry of the graph lying on x is equal to 0 line. So that is the axis of symmetry. So we call it a axis of symmetry, right? So the bottom line, the turning point, so we call it turning point. See, the graph come from here and go there, either come from here or go there. So what is the turning point here? Turning point is also 0, 0. Turning point is also 0, 0. Or the origin. We call this the origin of the graph, right? So it is origin of the graph. So that is the most characteristic features of this y is equal to x squared graph, right? So it has a symmetry on 0, 0, right? So turning point is 0, 0 as well. So that is the most special nature of this graph. So now we want to consider the transformations from y is equal to x squared. Transformations from y is equal to x squared. What do you mean by transformations, right? So transformations actually the variations, right? The changes happen to this y is equal to x squared, right? The quadratic equation, the most simplest form, as I said. So as the book mentioned, so this is, by the way, this is this regarding this book. This is Cambridge VC Unit 1 and 2 book, which is recommended book for VC student in Victoria. So book says the completing square, right? So that is the method actually using this polynomial form, right? Polynomial form of a graph So which is ax squared plus bx plus c, the polynomial form, can be converted into turning point form, right? So what is this turning point form? So this is what you call turning point form of the graph. So this is the polynomial form of the graph. So you can convert the polynomial point of the graph into turning point of the graph, right? Turning point equation, right? Turning point form of the graph by the process known as completing its graph. So we learned completing its graph before that, right? So what we look at, what is this turning point form of the graph? So you have y here, same as there. So you have a, right? So the polynomial before x squared is a. Now, to the a, we have add something minus hash, and not just x squared. This is x minus h squared, right? Plus k. So this is the, you got to remember this. This is the turning point form, right? So you understand why we call it a turning point form, right? So you can actually have the turning point in this equation embedded in here, right? So now in the turning point, what do you want to know about the turning point? If you have the symmetry of the axis, as we saw in previous one, symmetry of the axis is 0, right? On the zeros, x is equal to 0 line. So your h value, right, will give that symmetry of the axis. While, what is the significance of the k? The k value give you the y coordinate of the turning point. Right? K value will give you y coordinate of the turning point. Simple h value will give you the symmetry of the axis of the graph. So that's why we call this the turning point form. Understand? So we just get used to more details.